So we are dealing with the 10th problem in this series, and it is problem number 3.28. The problem is addressing inside a ball charged uniformly with volume density rho, there is a spherical cavity. The center of the cavity is displaced with respect to the center of the ball by a distance a. Then find the electric field strength E inside the cavity, assuming the permittivity equal to unity. So if we start solving this problem, then the first thing that we need to understand is the distribution of charge and the cavity which the problem is talking about. So over here we consider a spherical shell like this. It is a sphere, not a shell. A sphere is studded with charge, and inside this sphere is studded with charge, we are considering a cavity over here. Now this sphere is studded with charge, let us say having surface charge density rho, which is mentioned in the problem, and we are calculating electric field strength at the center of this cavity. So before we approach this problem, we need to understand some important results. So over here, if I consider a sphere like this, so inside a charged sphere, the electric field strength at a distance r having surface charge density rho is given as E equals rho r by 3 epsilon naught. So we have seen this on many occasions that if we consider at a distance r over here, then the electric field strength is written in this way. So vectorially we can write E vector as rho r vector by 3 epsilon naught. So this is the value of electric field strength inside the sphere studded with charge. Now over here in this problem with respect to the center O, the problem is asking us to calculate the electric field strength E inside the cavity. So over here, if I calculate electric field strength at any point over here, let us say P, this point is inside the cavity, so we are considering this vector as RP vector. The center over here is having coordinate RC vector, and inside this we consider this to be R2 vector. So if we consider this, so I can say that electric field strength at a point P is electric field strength due to the entire sphere, and if we subtract the electric field strength due to cavity, then we will get the answer over here. So for the entire sphere, if this cavity would never have been created, then the electric field strength would have been rho rp by 3 epsilon naught. Now if I consider only because of the charges inside this cavity, then it will be rho r2 by 3 epsilon naught, and this is the value of electric field strength at a point P. Now if I write vector equation for this triangle, then we can say that rp vector is equals rc vector plus r2 vector. That is, if two vectors are in order, resultant is third side but in opposite direction. So rp vector minus r2 vector can be written as rc vector, and hence electric field strength at any point P is written as rho by 3 epsilon naught rp vector minus r2 vector, which can be written as rho by 3 epsilon naught rc vector. Now this, the center of the cavity is displaced with respect to the center of the ball by a distance a. So this distance a is given to us, so we are writing answer in terms of a as rho a by 3 epsilon naught, and this is the answer for this particular problem, which is asking us to calculate electric field strength inside the cavity in a sphere.